Hey everyone, this video goes along with section 5.1 in your book, and that's about quadratic functions, and we are going to look at the graphs, which that's the one piece we haven't done yet. We've done a lot of other things with quadratics, so a lot of this should be kind of review, and then we'll build on that and get into some newer material. I'm going to talk about the different forms of the quadratic function, and I've matched it to what your book calls it. Depending on the publisher, sometimes things are given different names, so we'll talk about that too. So I briefly just want to pull up the book here and look at the quadratic functions. Make sure you read through this. There's always like this little intro part of a real world application. The objectives that we're going to do is look at the parabolas, talk about the vertex, minimum, maximum, and how we can maximize things, and do some word problems as well. So that'll be great. Here's another real world application you can read about. And then the characteristics of parabolas. Your book does talk about it. If you are not familiar at all, I feel like many of you are and you've seen it or whatever, but if it's been a while and you want to know the vocabulary, not only just read through the book, but look at the pre-lesson videos that I posted. They go through a great deal of more detail and lay it all out for you. So I think that you'll find that really, really helpful. And your book mentions how you find the axis of symmetry, but I'll go through that in my video as well. So make sure you read the book and go through those pre-lesson videos that I put in the assignment, or links to in the assignment. So before you watch this particular video, there's going to be, I think, 3. I'll try to keep it to. Some of it will overflow into next week with the word problems. For your quiz on Monday, you'll just need to know the basics of how to graph and some basic word problems and things. And then we'll get into more of the systems later. And just to clarify too, the quiz that I'm referring to, depending on when you're watching this and what term, it may not be a Monday. So it's just whatever on your pacing guide goes along with 5.1. Okay, so I'm looking up here at the top. The graph of a quadratic function is a parabola. We will be using 3 different forms of quadratic functions, all of which give us useful information about more specific details of the graph. So depending on what you need to know or what you're given, like different forms are better than others. But you can manipulate any one form into another using a variety of techniques, so we'll look at that as well. General form, sometimes it's referred to as standard form. In your book, though, its general form is your f of x equals ax squared plus bx plus c, where a is not equal to 0, otherwise it would be linear, not quadratic. This one is probably what you're most familiar with, and that's the easiest to get your y-intercept from. If you are talking about vertex, you might want to use vertex form down here because your h and your k are readily available. Sometimes it's just given to you like that. Also, if you're using transformations, vertex is form is really great. Another name that goes by is actually standard form. In this book, they use standard a lot, where other books, standard is the one we just referred to. I'll talk about each of these individually in a minute. Factored form is what we did a lot of, just factoring and solving quadratics. Here we're looking at expressions mainly at first, so we're not necessarily setting it equal to anything, but you will factor the expression, and if you have like a multiplier pulled out, that's a, and then here are your factors. So sometimes it's already laid out for you, or it's just easy to factor, and that's the easiest to get your intercepts from. Okay, so looking back at general form, we are going to talk about the y-intercept. That's when x equals 0. And so if I plugged 0 in for x in any of these spots there, I would just end up with c. So the y-intercept is at 0, c. To find the roots or x-intercepts of the graph, we need to set f of x equal to 0. So it's not automatically 0. Like when we were solving earlier in the term, we kind of got in the habit of just setting the equation equal to 0. So sometimes I think people just get in the habit of that all the time, but we do have to pay attention to what that means. That's really just giving us the intercepts when f of x equals 0. So we would plug that in. We could factor, we could use the quadratic formula, we could do a variety of techniques, and we would have a 0, 1, or 2 x-intercepts. So if you have 0 x-intercepts, then that means it doesn't touch at all. And I'll show you a little graph here. So if I just have a small little graph, here's x, here's y. Here's an example of one where I have 0 x-intercepts. It will never touch because it's, you know, increasing. My range is going up to positive infinity, but I am starting, my vertex is above the x-axis. Sometimes I would have 2 x-intercepts if it crosses over like this one. Other times I'm going to have 1 where I just end up sitting right on, just my vertex sits on the x-intercept or x-axis. So those are the, you know, different varieties. The vertex of the graph is easiest to find using this formula here, or not, well, it is a formula, minus b over 2a. You may have seen that before. And then we would take that input, that would be our input, plug it into the function, and we would find our corresponding y. So f of minus b over 2a would be our corresponding y. Okay, so I'm going to show you where that comes from. It comes from just taking, if you had, let me just get rid of this here. Actually, I'll leave that there. And we'll just look at this one where we have 2 intercepts. If I were to take and draw a little line down there, these are symmetrical, and that's why I want you to look at the characteristics video also, if you're not familiar. Especially if I would fold this in half, or this would be like a mirror, it would be reflecting over that line of symmetry, we call that. And I could actually find that by averaging my 2 intercepts. So whatever these are, I could find smack in the middle. I could take an average of those, and that would give me this point, and x, all the x's at that would give me my line of symmetry. Okay, so that's my line of symmetry. Now, how do I get that formula? Would be using the quadratic formula. So you probably looks like there's some familiar letters in there. So if I were to take the average of my quadratic formula, like the intercepts, I would end up with minus b over 2a. So I'm just going to show you really quick what that looks like. So we would have our axis of symmetry would be one of my intercepts, minus b plus square root of b squared minus 4ac all over 2a. And then I would add that, because I'm averaging here, minus b minus, that's the other intercept b squared minus 4ac, or the square root of that, right? All over 2a, and then divide by 2 because I have 2 items. I'm taking an average, so that's how that works. Then I would have a common denominator of 2a, so I could add these things together, and I would actually end up with minus b plus minus b would be minus 2b, and then these square roots of b squared minus 4ac and the minus square root b squared minus 4ac, those literally cancel out, right? So I have a 0 there, and then divided by my 2a, and then remember dividing by 2 is like multiplying by a half. And then if I were to reduce here, I would end up with minus b over 2a. So that is where that comes from. It's an average of your intercepts. So if you have factored form, I'm going to jump down to here where we have the factored form. If you already know your intercepts, you can actually average them and get your line of symmetry would be the r sub 1 plus r sub 2 all divided by 2, and then plug that in to get this corresponding y. Because remember, this axis of symmetry up here, minus b over 2a, it only gives you the x part, right? If I wanted to know this point, I would get the x value of my vertex, but I still have to plug whatever that is into my function no matter how I do it, right, to get my y value. Okay, so that's how that works. Vertex form is already laid out in vertex. What we do is complete the square. We take this general form and we do completing the square, except like earlier in the term, we always had our quadratic set equal to a number. Sometimes it was 0, or sometimes we'd have to get, we'd want to have it equal to a number, and then we'd add the half of b squared to both sides. Well, this time we're just working with an expression. We would take this general form expression and we would have to manipulate that to form our perfect square trinomial. And we can't actually add to both sides because there isn't 2 sides. We're just kind of changing the format on one side, on the right hand side or whatever it may fall. So we need to add what's called a 0 pair. We're just going to add, like, say if the number that comes out to form the perfect square trinomial is a 4, I have to just add 4 within a parenthesis and then subtract 4. So I'll go through that process with you in a problem line by line. I also posted an extra video on that, so you have all the steps. Your book does it a little differently. You can use that technique as well. They just figure out what the vertex is by using the line of symmetry and stuff and plugging in. So that's an option as well. So vertex form, f of x equals a times quantity x minus h squared plus k, where a is not equal to 0. Because again, if a is 0, then we're not going to have a quadratic. So this is the easiest form to get. Vertex form, the vertex is at hk. So be careful not to make it be negative. So if it's a minus, it's just going to be whatever h is. If it's a plus, it'll be the opposite sign. K is just the same. To find the roots or x-intercepts of the graph, we'd have to let f of x equal 0 and solve the resulting equation. We can use the square root method. The function will have a 0, we'll have 0, 1, or 2 x-intercepts, just like before. A little typo there, write R in. So be careful though, because of this. The y-intercept is not at 0k. to find the y-intercept, we need to let x equal 0. So that's a pretty common mistake because we're looking up here, oh, it's just the constant that's left. That's my y-intercept, but not the case when it's in vertex form, because this isn't going to come out just to be 0, this part. So we got to be careful with that. Factored form, we have here, you've worked with that a lot, f of x equals a times quantity x minus r sub 1, and parentheses, open parentheses, x minus r sub 2, and parentheses, again, a not equal to 0. Easiest form to get x-intercepts from. Okay, so the zeros of the graph will be r sub 1, comma 0, r sub 2, comma 0. You've done that a lot. You're setting each factor equal to 0. That gives you the intercepts. The vertex is always right in the middle of the zeros, so from this form, it's often easiest to find by averaging the x coordinates of the 0 that we talked about a little bit before. So we could do r sub 1 plus r sub 2 over 2 and then plug that in to get your y value, plug it into the function that you're given. You can also write the equation in standard form, and then you could figure out the minus b over 2a. For all forms, the sign of a indicates if the graph opens up or down. So sometimes we think of it as if a is positive, then you are in a good mood, so it's happy. So you're positive, right? So it's going to open up. If it's negative, you're in a bad mood, so it's going to open down, okay? Maybe have some angry eyebrows there. The size of the absolute value of a tells us how quickly the y values of the function increase or decrease. If the absolute value of a is greater than 1, then the function will be taller. It's going to be like skinny. It's going to shoot up fast. This is our parent function, would be y equals x squared. And if a is between 0 and 1, the absolute value, so if it's a fraction, whether it's negative or positive, a proper fraction or a decimal that's in between, the graph will be shorter than its parent function. So it's going to be going out slowly, okay? Pretend that's symmetrical there. I'll kind of fix that. So kind of keep those in mind. Also, we'll look back at vertex form for doing some shifting. We'll do that next week. I'm not going to talk about that now, but get in the habit of noticing what you're given, what the A is, what the vertex is, how it's changing in relation to this parent function, just so you're familiar. Okay, so that was the introduction of all of the vocabulary and things like that. So now I'm going to go through the examples, and I'm going to try to separate these out a little more and make them shorter videos and stuff. So that is our intro. So just some notes, not really anything to do, but wanted to walk you through that. So I'll make another part for the examples.